Hello, I'm Jason with scienceandmath.com, and today what we're going to do is build a very simple electric motor using items that you can find either from around your house or easy to find items at the department store. And before we even get started here, I want to say that when I was first introduced to this little experiment here, my mind was kind of blown away because it was very interesting and very easy to do. So what you need to do this is you'll need a battery. So in this case, we're using a AA battery, so that's what we have right here. Try to get a new one. The newer it is, the better the device will work. The next item you'll need is a wood screw. You can find these at any hardware store, anywhere. Just the length of it, you probably don't want to get it too much longer than this. You'll see why in just a moment. So maybe, 3 centimeters, 4 centimeters, something like that. You'll need a piece of wire. The length of the wire that you need is going to basically be dependent on the screw that we have, because in the end of the day what we're going to do is connect the top of the battery here to somewhere near the bottom of the screw. So you probably want something maybe 10 centimeters, 15 centimeters, something like that, but the length of the wire is not really that important. Now the most important thing that you'll need for this little experiment that we're doing here is a magnet. So here we have a neodymium magnet. This is called a rare earth magnet. Now any magnet will really work, right, that you might have laying around the house. However, the stronger the magnet, the better everything will work. The faster the motor will spin and the more impressive it will be. So I advise you to try to go to the hardware store and see if you can buy these things. If you can't buy them at the hardware store, go online. You can go to a search engine, type in rare earth magnet or neodymium magnet. Just do your best to spell it and it'll pop up in the search engines. You can get these for a few dollars. These are not very expensive. They're very lightweight. However, they're very strong. And so this is what you need for the basic contraption. Now what I have over here, this is sort of optional. I'm going to do this sort of for the wow factor. Here I have a flat battery. This is a 3-volt Energizer battery. You can buy these for $1 anywhere you can buy batteries. And here we have 2 light emitting diodes. Even though these guys are clear, we'll find in a minute that when we actually put electricity in them, they'll light up blue. Now everything over here is kind of optional. This isn't required to make the motor work. It's just going to make the motor a little more impressive. Now, why do I have a pair of pliers here? Because I really wanted to demonstrate before we do anything how powerful these neodymium magnets really are. They're very powerful. In fact, if you get a lot of these things, you have to be really careful because they're so powerful that as you pull them apart, if you've got a bunch of them stacked together, they can actually pinch your fingers a little bit, and they are powerful enough to kind of pinch your skin, so be careful. Let me show you what I mean. So this is a pair of pliers here. I'm going to put this right here in my hand. I'm going to put this neodymium magnet underneath, right? Now you can see that even through my skin, even through my fingers, this magnet is able to hold on magnetically to the metal pliers above it. So it's held on pretty nicely here. Now if we take the magnet and we attach it physically to the pliers, you can kind of hear the way it snaps. Listen carefully. It's pretty powerful. Now look at the way I'm pulling this off. If I try to grab this magnet and just pull it off, very difficult. I'm actually squeezing it very hard and I can't get it off of these pliers. The only way to really get it off is to kind of slide it to the edge like this, and then you can kind of work it off. So be careful. If you have 2 or 3 of these magnets, if you buy them in bulk or something and you kind of play around with them, they can snap together and pinch your skin. Trust me, I've done it. It doesn't feel very good. Now we always have our trusty safety glasses. We are going to wear these. You might look at this and say, well, there's no chemicals here, there's nothing that's going to happen, but trust me, you need to get in the habit of wearing some kind of safety glasses when you do these experiments, because you never know when something's going to fly up, fly in your face. You just want to get in that good habit, so always wear your safety glasses. All right, now to build the actual motor is very simple. What I'm going to do to make it a little easier to see is I'm going to take my black Sharpie marker here and I'm going to put some black lines around the circumference of this little magnet I have here. The reason I'm doing that is because this magnet is going to spin in a minute, and it's going to spin pretty fast. So really I want to give you some color around the edge of it so that you can actually see it spinning. It's just going to help visualize what's going on. Obviously you don't need to do this for the actual thing to work. So I'll put this marker over here to the side. So we'll give that just a second to dry. Now what I have here is a wood screw. These wood screws should respond to a magnet. So you just go ahead and pick the magnet up. You see how it just lifted right off the table like that. And it's a nice healthy, strong grip that it has here. Now the next thing you want to do is you want to take your AA battery and just put it right on top. Now what's happened here is that once we attach this magnet to this screw, this magnet is actually so powerful that it temporarily magnetizes this screw, right? So this screw, I'll just show you real quick, take that off. This screw is not magnetic at all. I mean, nothing happens here when you try to attach this guy. But once we put the magnet attached to the screw, then we attach it to the battery. Battery's obviously metallic. Then what we've done is we've magnetized the screw enough so that it actually holds on to the battery. So this is actually most of the motor that's built right now. We have a AA battery, we have a magnetized screw that's held onto the battery because of magnetic forces, and obviously it's attached to the magnet down here. Now to actually make this thing spin around and around as a motor would, what we do is we take one side of the wire, attach it to the positive terminal of this battery up here, and just kind of hold it with our finger, just like this. The other guy, we're going to reach down below and actually touch the magnet itself. Now watch carefully what happens at the moment we do this touching here, right down here on the magnet. You can see right there, the whole entire apparatus starts to spin. It'll slow down due to friction, and we can just, when we're ready, we'll touch it again. And we see that we've got a nice, good speed going. You can see this guy's spinning pretty rapidly, in fact. So let's watch it slow down. Actually, it's spinning so fast you can't see the black lines that I painted on. Whenever we slow down just a little bit, you'll probably be able to see those. So you can get quite a bit of speed out of this thing. Now, the only thing you have to really be worried about as far as danger here is the longer you hold this thing here, as soon as I hold this guy here, then what I have is electric current flowing through this wire. So your finger is up here at the top touching it. Your finger can get a little bit warm because of the electric current there. So this is your basic electric motor. Right now, if you take a motor off the shelf, you know, that you might find in an electronics kit or some other kind of motor, and you cut it open, what are you going to see inside? You're going to see magnets and wire. That's basically what a motor is. You have a magnetic field that's coming out of this magnet, right? And then you have electricity flowing in that wire. And somehow we kind of take it for granted, but we know that those two things, the magnetic field from the magnet and the electricity in the wire, somehow produce motion. So what I would like to do before we kind of get to our grand finale here, which is what will be with these lights, is I'd like to try to explain why this is happening, because doing science experiments is great. Doing demonstrations is fantastic, right? Science is really amazing, right? We can see here with a battery, a screw, and a magnet, and some wire, we can produce a motor. That's pretty cool. But more importantly, we need to know why it's happening. We need to know, or at least try to understand, what's really going on. Now, what's happening here is at the moment that we connect this guy, obviously nothing at all is happening right now. There's nothing going on. But what happens is as soon as I touch this wire to this magnet, by the way, this magnet conducts electricity, and this screw also conducts electricity. So at the moment that I touch this guy down here, electricity flows through this wire down to the magnet, right? And once it gets to the magnet, it flows through the screw because the screw also conducts electricity, and then that electricity flows back up into the battery, and so you have a circuit here. So the entire time, obviously I've let go, so nothing's going on, but as soon as I touch it again, like this, right, electricity flows, the circuit is completed, and then the thing starts to spin. The question is, why does it actually spin? Well, it turns out that, you know, we all have played with magnets, right? We know that magnets attract. We also know that magnets can repel. We've talked about this. We've learned this when we play with magnets as a kid. It turns out magnets can attract and repel. But there's a force there between the magnets, but there's also a force when you have a wire carrying electricity that's immersed inside of a magnetic field. There's going to be a force that pops up there. Basically, electricity flowing inside of a magnetic field is going to arise and come up with a force. It's very similar to the force that happens when you take two magnets together that just pops out of thin air, right, when they come close to one another. In this case, it's because of the electricity. The only catch is the direction of that force that kind of pops up whenever you have a wire carrying electricity in a magnetic field. That force is always going to be perpendicular to the magnetic field that's there and to the electricity that's there. So let me take this guy apart to kind of show you what's really happening in stages. We have the battery, we connect this guy to the top, and electricity comes down here. Now I've removed the screw just so you can kind of see what's going on, but I think you can understand that once the electricity makes its way, I'm going to use the screw to point here, once the electricity makes its way down to the magnet, right, the electricity flows into the magnet right along the top here, and then it goes into the screw back up to the battery. So what we have here really is we have electricity flowing into this magnet here across the top, right, going in like this, and then of course once it gets to the screw it goes up the screw. So we have electricity flowing across the surface of this magnet here towards the screw as it makes its way back. Now also on top of this, you can't see it, right? You can't smell it, you can't taste it, but you know that there's a magnetic field here. And if you could put on some kind of like magnetic field goggles and see it, what you would see is this magnetic field would start here and it would come up all the way around and it would come back in to the bottom of the magnet. And that's all over the place. It's coming around top to bottom, top, all the way around, top to bottom, like these little donuts all the way around. So what you have here is a magnetic field coming straight out of the top here. If you can envision, this screw is almost like the magnetic field coming out as it bends over, of course. But here, right at the surface, it's coming out. And we've also said that we have an electric current that's kind of flowing this way because the electricity is going in and then up. So what we have here is a magnetic field coming up and an electric current going in. So we have a magnetic field going up, an electric field coming in. So what's perpendicular to these things? If I have electricity going this way, magnetic field going this way, perpendicular would be this way. So what's happening is I have electric current going this way, and I've got a force that pops up that's perpendicular to this magnetic field and perpendicular to this electric current, which turns and pushes the motor this way. And so since this guy is basically suspended on a pivot point here, the force that pops up just simply turns the thing. So I have my electric current going into the magnet up there, up through the screw, and because I've got that there going, then I've got a magnetic field, I've got an electric current, and the force that pops up is perpendicular to them both. And that force just simply acts to turn the magnet, right? Now let me kind of expand on this a little bit and kind of show you something neat you can show your friends. Let's go ahead and do exactly the same thing. We've built the motor, we've discussed what's really going on here so you understand what's going on, but let's kick it up a little bit and make it interesting. Here what I have are two light emitting diodes. They're clear, but you'll see in a second they actually shine blue light. And here we have a very thin battery. Now if you hook this guy up in the proper direction, you can see that you have a blue light that goes in there. Now if you accidentally hook the LED up backwards, nothing will happen. That is just the way LEDs are made, so don't worry too much about that. You just flip it over until you see the light coming out. And of course I've got another one here. So you see in this case, I've got two blue lights. If I accidentally hook that one up backwards, I've got nothing. That's just the way these little diodes work. So just hook it up until you see the two lights. So what I would really like to do is go ahead and hook this guy up like this, right? And then stick it to the bottom of my magnet, just like that. Now I've got a light that is on. The magnetic force is holding it to the battery. That's all that is. Instead of putting glue there or something, I've got that covered there. And then I'll take another one like this, and I'll stick it through to the other side. So really what I got to do, just to make it a little bit easier, let's just do it this way. I'll put these guys on, kind of hold them with my fingers, right, like this, and then I'll take this guy and I'll sandwich it in like this. So here I have a little helicopter looking thing. That's kind of neat. I've got two lights, right, that basically are attached and held like this on the bottom. Now, what I'm going to do is hook it up exactly like this. So I have exactly the same contraption, it's just that I've got two lights that are now connected there as well. So let me go ahead and hook the top together, and now I'll touch my magnet, and if I do it right, I've got a nice little light show. And if you're patient, you can get this guy spinning really, really fast. Of course, if you have everything centered properly, everything balanced properly, you can get this thing going really nice. And if you turn the lights out, this looks really impressive in the dark as well. Okay? So notice the direction this thing is turning right now. it's turning, when you're looking down, it's turning clockwise, right? It's turning clockwise. The same way that the hands of a clock move. Now let me show you what happens. Since this force that actually pushes the magnet is dependent on the current that's going in the wire, and it's also dependent on the magnet, if we flip the magnet over, that's all I've done, flip the magnet over, then what should happen is it should spin the other way. So instead of clockwise, it should spin now counterclockwise. So let's see if that actually happens. So let me put this guy here. I'll attach this guy and try to get both of these wires there. And then I'll attach that to the top. And now let's hook it up and let's see. And now it's spinning the opposite direction. It's spinning counterclockwise. And I'm getting a nice little spin out of this guy here. So there you go. All right, so that's how to build a very simple motor. All you have to have is a AA battery, a magnet, a very strong neodymium magnet, a screw, a metal wood screw, and optionally a nice watch battery or some kind of a 3-volt cell that's strong enough to light these little light emitting diodes up. And there you go. You can build that simple little contraption in just a few minutes, and you can really use it to explain to people how motors work. Fundamentally, every motor has to have a magnet, right? That's what we've supplied here. It has to have some kind of electricity, and there's a force that arises because in magnetic fields, when you have an electric current going inside of a magnetic field, then a force is going to pop up that's going to be perpendicular to the electric current that you have and also perpendicular to the magnetic field. That force in this case acts to spin this thing in a circle, and that's exactly what we have here. I hope you've enjoyed this guy. Go get these materials. They're very easy to obtain. It's a very simple, safe thing to show your friends, to show students, to show kids, and it's actually really, really neat too, especially if you go and take the time to get the light emitting diodes with a little cell there. You can turn the lights off and give yourself a really neat light show.